Hi everyone, this is TSR. In all our previous classes, successfully we completed first chapter up to exercise 1.5 including logarithms. Now today with the support of you, we are entering into sets. Sets is a very good and very simple, very important topic for public examination point of view. Topic is simple but weightage is more in board examination. Very simple to understand. Let us start that one. But there is again, as I told you before, there is a lot of concept for sets. Coming to the 10th class and board examination, we have very few concepts or topics in sets to discuss. Okay na? I will cover them by taking most important problems from the exercises. 4 exercises are there. Among them, most important model problems are based upon very simple and concepts. Okay na? Very simple concepts, right? Okay, so what is the meaning and definition of set? Set means collection of well defined objects. Got it? Set means collection of well defined objects. What is the meaning of well defined? Well defined means that condition or that statements regarding the objects should be same throughout the universe. It should not be differ from place to place or person to person. It should be same throughout the universe regarding the objects. Then that statement is called well defined. Simple example I am asking, rivers in your country. I am asking rivers in your country. Okay, for this statement, answers in the complete India, persons will give Ganga, Yamuna, Godavari, Krishna, Tungabhadra, like that. But when we go for Japan, they will give their country river names. Coming to Pakistan, they give their country river names. Okay na? So for this statement, answers from person to person will be differ in the universe. Okay, different country peoples will give different river names, depends upon their country. Okay, that's why the answer of this statement will not called as well defined. Got it, Nana? Whereas the statement, that's why this answer of this statement will not represent a set. Whereas rivers in India, if I said what are the rivers in India, so for this question or for this statement, answer will be same in the entire universe. Means Indian persons will give Ganga, Yamuna, Godavari, Krishna, Tungabhadra and so on. Whereas the Japanese or Chinese or Pakistanis, Australians, they will also give same Ganga, Yamuna, Godavari, Tungabhadra, like that. Okay, Nana? So the answer of this statement will be same in the entire universe. That's why that objects collection will be called as well defined. Got it, Nana? So remember that one. That is the basic important point to understand about the definition of set. Collection of well defined objects. Well defined means universally the collection will be same. It should not be differ from person to person, right? That type of sets will be written with this bracket. This bracket is called simply flower bracket, but mathematically this is called as parenthesis. This is called as parenthesis. And the sets will be represented with capital letters, capital A, capital B, capital C, like that. Whereas the objects are elements. Objects are elements in the set will be represented with small letters, small a, small b, small c, small d, like that. Okay na? Simple examples I would like to give you. Okay na? Example. For example, collection of natural numbers, that is also called as natural number set or set of natural numbers. Already I told you in the previous chapter, it is represented with n, which is equal to set of 1 comma 2 comma 3 comma 4 comma and so on. Got it, Nana? Right. And collection of vowels in English alphabet. So that is set of a comma e comma I comma o comma u. Is that clear, Nana? So this can be represented with capital letter A. For my choice, A is equal to set of vowels in English alphabet a comma e comma I comma o comma u. Okay, Nana? Right. Next, I am taking what is the even prime number. So then we have to take 2, only 2 in the set, that is set of 2, which is equal to some other set b. B is equal to set of 2, which is called as even prime number, set of even prime numbers. Like that, sets will be represented with capital letters, whereas the elements in it will be represented with small letters or numerals, like that according to the condition. And the specific condition in sets is you should not repeat the elements. You should not repeat the element. Repetition not allowed, and commas has to be taken in between the objects. Okay, Nana? Right. Next, this is the main concept. Based upon the number of elements in it, we can tell one word, that is called as cardinality. Number of elements in the set. What I am saying? Number of elements or objects in the set will be called as cardinality of the set. Okay, na? Right. For example, natural numbers n is equal to set of 1 comma 2 comma 3 comma 4 comma and so on. Okay, na? Right. How many elements are there in this will be represented with n of n, number of elements in the natural number set. This is called cardinality. Cardinality of the set representation is equal to how many natural numbers are there for us, and so on, means infinite. Correct, Nana? Right. Whereas the second set, vowels in English alphabet, I am taking it as A, which is equal to set of a comma I comma e comma o comma u. This one is set of vowels. So its cardinality will be represented with n of a. Am I clear, Nana? Is equal to how many elements are there in this? Countable. 1, 2, 3, 4, 5. So 5 elements are there. Whereas even prime, set of even primes as a set, I am taking that one as b is equal to set of 2. Okay, comma n of b, number of elements in b is equal to how many are there? 1. In the same way, how many negative natural numbers are there? Set of negative natural numbers I am asking. Are there any negative natural numbers? No. Set of negative natural numbers means there will be a set without any elements, negative natural numbers. Okay, so that set can be taken as C. C is equal to set of nothing, no elements in that. So that type of set which is having no elements in this is called empty set. That is called empty set or null set or void set, empty set or null set or void set. Okay, that type of empty sets are represented with pi. This is the symbol. Pi is equal to only set symbol without any elements. Okay, Nana? Right. Now coming to the speciality of this null set, you will be having a choice to ask one more questions in bit part of the public examination. What is that one? So pi means, they will ask you, pi means. What is pi means? Set with no elements. So pi is not equal to set of 0. Set of 0 means set is having one element in it, whatever that it may be, it is a singleton set, one element is there inside, so pi is not equal to that one, keep it in mind. Or pi is not equal to set of pi, pi is not equal to set of pi, and pi is not equal to 0. Okay, so these are the different type of wrong answer that they can give in multiple choice questions, but the correct answer is this one, pi equal to set with no elements. Okay Nana, keep it in mind, this is very important one. Next, if a set is having only one element in it, that is called as singleton set. Singleton set. Okay Nana, singleton set. This is the main and major concept regarding sets. There is a lot, but this is the major concept. After the discussion of this topic, we need to introduce one more topic regarding sets. That one is representation of sets. What is that one? Representation of sets. Sets can be represented in two models. One is roster form. One is roster form. Another one is set builder form. In two different models, you can represent the sets. Okay, what are they? Roster form, set builder form. What is that one? What is the roster form? In the roster form, set contains directly elements in it. You can see the elements directly in the set. Okay na? You can see the elements directly in the set. That type of representation is called roster form. In the previous example I wrote na, those are all. For example, n equal to set of 1 comma 2 comma 3 comma 4 comma and so on. This is natural number set. You can see the elements, first element, second, third, fourth. This is called roster form. Okay, next, a is equal to set of a comma e comma I comma o comma u. This is set of vowels in English alphabet. Okay na, you can see the elements directly like that. Whereas the set builder form means, in its name only you can observe, you can build the set by a statement or by a definition. Whatever the well definition earlier we used, that definition form you will be having in this set builder form. So you cannot see the direct elements like this. You can see their well definition, their statement form. Okay, for example, same set which is there in roster form as example 1 will be written in the set builder form as n is equal to set of x such that x is a natural number. Natural number. That is the set builder form. Here you cannot see the elements directly. You can see only the well definition form of that one. Here it is equal to a is equal to set of x. Set builder form is regarding x, element x. What is that x? Such that x is an vowel in English alphabet. In English alphabet, like that. Is that clear, Nana? For example, I am taking another set B as example 3. Set of minus 2 comma minus 1 comma 0 comma 1 comma 2 comma 3. This one. This is set builder roster form. We need to convert its set builder form. Means its definition we have to write, which reflects only these elements, not one element less than them, not one element more than them, only its representation in definition form. So I can write it as B is equal to set of x such that x belongs to z, x is an integer, comma, minus 2 less than or equal to x less than or equal to 3, like that. This is the definition form, well definition form of set builder form. you can build the set with this form. So direct elements will not be here, its definition will be there here. Is that clear, Nana? B is equal to set of x such that x belongs to z integers. How? What kind of integer? Minus 2 less than or equal to x less than or equal to 3 means starting from minus 2 including equal to it up to the integer 3 including it. This is only na minus 2, minus 1, 0, 1, 2, 3. These are the integers according to this one. So you can convert roster form to set builder form to roster form. Very, very, very important for bits for 1 mark also. And especially in the long answer questions, means either for 6 marks or for short answer questions 4 marks, they will ask you the operations of sets, union of sets, intersection of sets, subtraction of sets, but sets will not give you directly in the roster form. Most of the question papers are containing set builder forms of the sets will be there. We need to convert them into roster form to operate them, to union, to intersection, to subtract. Okay na? So conversion is very, very important. So roster to set builder form conversion we have taken na. In the same way we will take set builder form to roster form. For example, C is equal to set of x such that x is a multiple of 5. X is a multiple of 5. So C contains the elements like x. Who are they? That x is a multiple of 5. 5 multiple means its roster form. Set of 5 ones are 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, comma and so on. How many multiples they are asking? They did not inform. Just multiples means and so on. So that is the set roster form of this given set builder form. Okay, Nana? Right. So like that, roster form to set builder form to roster form conversion you have to practice. Is it clear? Based upon this simple content, you can get very important questions, and those are there in exercise 2.1 as 5, 6, 7 bits. Okay, Nana? Right. Okay, Nana? Based upon the previous concept, just observe the important questions 5, 6, 7 from exercise 2.5. These are the very important questions for public examination point of view. I am considering them only. Okay, na? Right. What is that fifth question contains? Write the following in roster form. They are asking write the following in roster form. Means they are trying to give us in set builder form. Let us observe that one. First question, set B is equal to set of x such that x is a natural number smaller than 6. X is a natural number. Identify the important words in mathematics. Natural numbers who are smaller than 6. That is the set builder form. What is its answer, Nana? So B is equal to set of natural number smaller than 6 means 1, 2, 3, 4, 5. That's it. That is the answer for that one. Okay, na? For that 1 mark we will get, but numerical changes will be there. Next, coming to the second question, C is equal to set of x such that x is a 2-digit natural number such that sum of its digits is 8. It is a 2-digit natural number, but if you add both the digits you should get 8. So for that answer C is equal to, if you choose 0 as the tens one, 0, 8 sum of the digits, 0, 8 sum of the digits is 8 only, but it is not a 2-digit number. So that's why we are not supposed to consider that one. Next chance, 1, 7. It is a 2-digit number. Sum of the digits 1 plus 7 equal to 8. Next 2, 6. Next 3, 5. Next 4, 4. There is a pattern. 5, 3. Next 6, 2. Next 7, 1. And you can take 8, 0. 80. 080 is not considerable, but 80 is a 2-digit number 80. So in every 2-digit number, sum of the digits is 8. This is the answer. Okay, Nana? Most of the students will forgot to write 80, or they will write 08 also. The question is very simple, but because of that small confusion, we will lose the mark, even though the remaining numbers are right. So that is the most dangerous thing in sets. If we wrote any one element wrong, automatically total problem will go wrong. So be careful, think and answer. It will take less time to answer. Okay, na? 1 mark, important question. Next, third one. D is equal to set of x such that x is a prime number which is a divisor of 6, which is a divisor of 60. Okay, na? 60 divisors, write the product form, nana. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7, 8 possibilities are not there. So this is called product form, right? So these are the divisors. Among them, who are the primes? 2 is a prime, 3 is a prime, 5 is a prime, because we need only those prime numbers. And which are the divisors of 60? Next, 6 is composite. 1 is neither composite nor prime. So what are our required prime numbers? 2, 3, 5. That's it, Nana. This is D. Very, very important model for 1 mark or 2 marks, right? Now, what is the last question in this fifth one? E is equal to set of x. X is an alphabet in better. Actually, elements of the sets will be generally considered with small letters, whereas the letter is given as capitals. Whereas the letter is given as capitals, we have to consider the elements in small letters. Since it is in capitals, their alphabets has to be taken in capitals only. So its set builder form conversion is roster form. E is equal to alphabets in the letter better means B comma E comma T comma one more T, repetition not allowed. E already came, repetition not allowed. R. That's it, Nana. This is the roster form. Clear? Okay, Nana. Now we will go through sixth question. What they are saying? Write the following sets in set builder form. Quite reverse of the previous question. So they will give the sets in roster form because they are asking to write their set builder form. What is the first question? First one is set of 3, 6, 9, 12. You have to observe the pattern or well definition regarding these elements. If you observe them, 3 1s are, 3 2s are, 3 3s are, 3 4s are. These are 3 multiples. But how many multiples? Infinity multiples are not there here. Ends with 12. So it is a finite set with a finite number of elements. So we have to represent 3 multiples up to certainty, up to certain numbers based on this. So this is equal to set of x such that x is a multiple of 3 less than 15 or 13, like that you can take. Understood, Nana? One more choice also there. Same set can be written as set of x such that x is a 3 multiple 3m, comma m is a natural number, comma m is less than or equal to 4. Got it, Nana? X such that x equal to 3m, 3 multiple. How many multiples? Natural numbers up to 4. 3 1s are, 3 2s are, 3 3s are, 3 4s are. That is this representation, both represent this only. Different styles. Because in public examination, specially they will ask you for 2 marks, like they will give roster form like this. write this set in two different ways of set builder forms, they will ask you. Then this type of practice will help you. Okay nana, right. Coming to the second question, it is equal to set of 2 4 6 8 16 32. What is that? Observe this. This is 2 1s are 2 2s are 2 3s are 6 not there, so it is not a 2 multiple. So don't go in a regular pattern. So check all the elements. Now come to this. 2 power 1 2, 2 square 4, 2 cube 8, 2 power 4 16, 2 power 5 32. Ends. Finite set that ends. So that clear explanation in set builder form you have to write. This is 2 powers x such that x equal to 2 power n, 2 power n comma, what is that n? Regarding this n, it is a natural number up to how many? 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, comma n less than or equal to 5 you can take, or n less than 6 also you can take. Less than or equal to 5 is one style, less than 6 is another style, different methods. Or like this in words also you can explain. Okay, habituate that. Next, coming to the third question, set of 5 comma 25 comma 125 comma 625. In this you observe that 5 power 1, 5 square, 5 cube, 5 power 4, 5 powers. So set of x, the x is such that x equal to 5 power n model, whereas n is a natural number and n is less than or equal to 4, 5 power 4, 5 power 4. So n is less than or equal to 4 you can write, or n is less than or equal to 5 also you can write. Okay na? One model here, one model here I wrote. 5 power 1, 5 square, 5 cube, 5 power 4. Natural number up to 4 only. So n less than or equal to 4 you can write, or n less than 5 also you can write. Different styles. Okay nana? Right. Coming to the last problem in this. Set of 1 comma 2, 4 comma 9 comma 16 comma 25 comma and so on up to 100. This is also a finite set. But what is the pattern here? Logic here. You observe them. What these are all? 1 square, 2 square, 3 square, 4 square, 5 square up to 10 square. These are all squares. Square, upper value square is fixed. Base is changing. 1 square, 2 square, 3 square, 4 square. So which is fixed? Power 2. Who is changing? Base. So that explanation we have to write. So this is equal to answer. Set of x such that x equal to n power 2, n square value. It is a square of different numbers. So who is that n? N is a natural number, comma n less than or equal to 10. 1 square, 2 square, 3 square up to 10 square we have to take, or n less than 11 also you can take. Different models. Okay, this ends. Okay nana? Now we will go through question number 7. What is it? Write the following sets in roster form. Means set builder to roster form they are asking. Few questions I am taking. Among them first one is a is equal to set of x such that x is a natural number greater than 50 and smaller than 100. Only natural numbers we have to take. Remember that one. It should be greater than 50 and less than 100. Okay. Whatever the important words are there, immediately you have to underline them with pencil or pen. Then focus will be more on them. So the answer will be a is equal to set of, what is the natural number greater than 50? First one 51, next 52, next 53, comma and so on up to smaller than 100 means 99 only na. That's it. 1 mark we got. That's it. Next, coming to the second one, b is equal to set of x such that x is an integer. What is this here? Integer. in this natural number. Which kind of integer, what it has to do? It should follow the given condition, x square equal to 4. So b is equal to set of x such that x is an integer, x square equal to 4. X value has to satisfy this as an integer. So what is that one? If x square equal to 4, that implies x equal to plus or minus root. Square will go to the other side as plus or minus square root. Okay, Nana? So that is the basic point we should have to remember. Square will go to the other side of the equality as plus or minus root of the other side value 4. That's why plus or minus root 4 value 2. So x is having two chances, plus 2 or minus 2. Since they are asking x as integer, plus 2 will be valid, minus 2 will also be valid. So the answer will be b is equal to set of minus 2 comma 2. That's it. If the same problem in the exam as an application skill, if they ask x is a natural number comma x square equal to 4 means actually x gives you plus or minus 2 only, plus 2 minus 2, but they are expecting x as natural number, so minus 2 will not be valid, only 2 we have to take, whereas it is a natural number. Understood, Nana? That is the speciality. Remember that. Second question over. Fourth question I am taking is equal, e is equal to set of x such that x equal to 2n square plus 1. What is the element? Element is like 2n square plus 1 form. In this, who is n? Minus 3 less than or equal to n less than or equal to 3, where n as a integer, n as an integer. Okay, Nana? So what are the chances of that n? Integer starting from minus 3 to 3 means minus 3, minus 2, minus 1, 0, 1, 2, 3. These are the chances of n. If n is taking these chances, so what is x will take? X will take, substitute that one. Substitute minus 3 in its place. X equal to 2 into minus 3 whole square plus 1. 2 into minus 3 whole square plus 1. So numerical calculations. This is 2 into minus 3 whole square value 9 plus 1. 2 9s are 18 plus 1 is 19. So at minus 3 x is giving us 19. Same model. If x value is minus 2, substitute here. X value minus 2, it implies x equal to 2 into minus 2 whole square plus 1. This is 2 into 4 plus 1, that equal to 9. Okay, Nana? So 9. Next, x equal to minus 1 gives you n equal to minus 1 gives you x value 2 into minus 1 whole square plus 1, which is equal to 2 into 1 plus 1, that equal to 3. Calculations you have to do. Next value 3. Got it? Next, x value 0, n value 0, sorry Nana, n value 0 gives you x value as 2 into 0 square plus 1, 2 into n square plus 1, which is equal to 2 into 0, 0 plus 1, answer 1. This is equal to 1. Okay, na? Next, x value 1 means 2 into 1 square plus 1. Same 2 into 1 plus 1, 3 will comes. Okay, Nana? So 3 will comes, but elements are not repeated under repetition. So for 1 you will get 3, for 2 you will get 9, for 3 you will get 19, but repetition not allowed. So this is our required set. By substitution and simplification you will get the result. At 1, 2, 3, same results 3, 9, 19 will be repeated, but in set repetition not allowed. So we will write only its answer as E is equal to set of 19 comma 9 comma 1. Okay, Nana? This question is having little bit more calculation. You have to show that calculation in the paper itself in your presentation. So automatically guess it. This is not a 1 mark question. This type of questions you can expect in either 2 marks or for 4 marks, depends upon the calculation part. Okay Nana, have a good day.